This is Math 2, Unit 3, Lesson 3A, Notes. It's going to be titled Proofs Using Reflexive Property of Congruence. Okay, what is the reflexive property? We've talked about this already. We had this on a previous worksheet in class. Reflexive property is pretty much when anything is equal to itself. Anything is equal to itself. So, pretty much saying x is equal to x. Or angle B is congruent to angle B, or side AC is congruent to side AC. This is the one we're going to be using more of in this lesson for the reflexive property of congruence. The side AC is congruent to side AC. Now, it's not always going to be a side that we're dealing with, but for this particular lesson, it is going to be. All right, so pretty much what this means is, let's draw this picture. Have you draw two lines like so. Try to find the middle and connect and connect. And connect down there. All right, I'm going to call this A, B, C, D. Okay, now if I gave you, I'm going to retrace this in pen so we can keep track of our original picture. If I gave you, if it was given information that this top left angle, that's angle ABC, is congruent to angle DBC. So let's pretend those markings are already given to you, as well as two little angle markings down in the bottom corners. Can you prove these triangles are congruent? With just those markings, not necessarily, but because BC is congruent to BC by the reflexive property, we can now say the two triangles are congruent by angle, side, angle. Do you see that? Angle, side, angle. The side is sandwiched between. So the two triangles are congruent by angle, side, angle. All right, let's just get practice writing our statements. I would say triangle ABC, our congruent statements would be triangle ABC is congruent to triangle, okay, so I went ABC, I went from no angle marking to 1 to 2. None, 1, 2. None, 1, 2. So that's triangle DBC. You want to make sure you're going in order. Okay, so let's try a proof. Number 1, you will always be given information. Given PQ is congruent to TR. Side PQ is congruent to side TR. And QR is congruent to PT. Prove, now before I give you the prove, what I want you to prove, I'm going to draw the image because right now it doesn't really make any sense. Okay, so let's draw like a parallelogram type image. Okay, I'm going to have you, we're going to label this P, Q, R, T. I'm going to have you connect P to R, so make a diagonal across like so. Okay, now let's label the given information. PQ, that's here, is congruent to TR, so those two sides are congruent. QR is congruent to PT, so I put two side markings. Can I prove what? I'm going to try to prove that triangle PQ R is congruent to triangle blank. Now, I don't know what triangle I'm trying to prove it. This is how it's gonna be on your worksheet. They're gonna be giving you some blanks here and there. So, right now we may not have enough markings. You might feel that you do. Let's see, PQR, PQR. Actually we do, because we go up the single and across the double. Single, double. So you go single, double. Do you see that? PQR, RTP. So let's go ahead and write that down. RTP. So that's not going to be given to us. We have to fill that in on our own. All right. And this is how you set up your 2-column proofs. We're going to always have a side that is your statement, statements, and then your reason. Why did you write that statement down? Statement 1, reason 1. Statement 1 will always be the given information. PQ is congruent to TR, and QR is congruent to PT. And what's the reason? Given information. That should always be your first line. I mean, some proof writers won't always do it this way, but in this class, for the most part, given is your line 1, your statement 1, and your reason will always be given. It was given, it was free, given information. Number 2, P is congruent to PR. Blank. And then you'll be asked to fill it in. So why are they congruent? So they're saying right here, PR is congruent to PR. I'm going to put 3 markings. Why is PR congruent to PR? First off, do we agree that PR is congruent to PR? Yeah, that's something we would say if we were looking at this triangle. And the reason is reflexive property. All right, number 3. Now that I have all the markings down properly, can I say the 2 triangles are congruent? I sure can. What's the reason? There's 1, 2, 3 side markings. 1, 2, 3 side markings. We'd say the 2 triangles are congruent because of side, side, side congruency. So we can now say triangle PQR is congruent to which triangle? RTP. And the reason is side, side, side. All right, so your proofs will always be set up. First statement is whatever they gave to you, and the reason will always be given. The middle part of it, there's only one step in the middle, but the middle part will always be like the meat of your problem. All the little bits and pieces that you can say are congruent or whatever it is you're saying about the problem. Your last step, which is the third one in this case, is what you're trying to prove. I can now say PQR, triangle PQR is congruent to triangle RTP. That's what I'm trying to prove. And your reason is why. Why are you able to say that? In this particular case, it's because of side, side, side. On some of your previous worksheets, for example, I'm going to put one up here really quick. Like something like this, you would say, oh, they're congruent because of side, angle, side. But again, you'd have some steps in there first. Something like this. You would say this diagonal is congruent to itself because of reflexive property. Therefore, the 2 triangles are congruent because of hypotenuse leg. So, if you feel like, oh, I don't get this, we will do a bunch of them together in class. So come prepared, be ready, ask questions if there's anything you're not sure about. That is it for this lesson.